of law of reflection, laws of reflection using Huygens principle. Already laws of refraction using Huygens principle I discussed, right? Now here what you do, here one picture you have a mirror, one reflecting surface. Okay, when you talk about reflection, definitely surface will consider m prime. Now this is a reflecting surface. Now what you do, you take a ray. You take a ray of light. Okay, one parallel light rays you take, parallel light rays, the parallel light rays. Now make a perpendicular like this. Make a perpendicular like this. Now this will be your incident wavefront. This will be your incident wavefront. Remember parallel light rays. This is the light rays. The parallel light rays coming. Huh? Case 2 that is same only. That is refraction at denser medium and refraction at rarer medium. That is same only. Okay. What derivation you did there in case 1, same derivation you can do for case 2. No worries. Now reflection understand. Now see here. Laws of reflection is basically angle of incidence equal to angle of reflection, right? That one will prove. How will prove? Now here I will take one normal. Now this angle is I, and this will be a reflector. I consider this a reflected ray. Reflected ray I will consider here. And this is the reflected ray. Now this angle is R. Is I equal to R? I need to prove. Before that, I will make a line here like this. Now this point I will give A. This point is C. This point is B. And this point I will give as E. And here to here distance, I will remember it is V tau. Here to here distance also V tau. V the speed of light in this medium. So distance equal to V into tau. Now reflecting surface. Maybe this angle is I. This angle also I. This angle R. Now if I will see, by seeing ABC and AEC triangle, how it is coming? Now triangles are coming like this. Triangles are coming like this. Don't talk. A, B, C, E. One side, this side is common. This side is common for both, and this is also common. Like equal. B tau, B tau. If this type of condition coming, then this angle I should be equal to angle R, because A and B are congruent triangle. Which triangle? Congruent or similar triangle you can tell. Okay, congruent triangle. The congruent triangle, then I can tell I equal to R. So this is 3 mark question will come, or 2 mark question. Okay, in board exam or a pre-board exam. Okay, but language and all you give whatever given, how it is done, like that you check. So the 2 triangles we consider there. Incident wavefront. This is reflected wavefront. This one you can tell. These are incident wavefront. Okay. These are incident wavefront. Incident wavefront. This one you can tell reflected wavefront. Reflected. Reflected wave. That is what the derivation. Okay. 2 triangles you have to take, and to prove that the 2 triangles are congruent. If congruent, na I equal to R. That's it. Okay. Part is over. Reflection part. Now all of you listen next part. Next part listen. One important notes you can write there, already written in classwork. You practice this. Number 1. If a prism is there, I am taking some plane wavefront. Here what have plane wavefront I have taken? Plane wavefront. Plane wavefront means what? Light rays are parallel coming. Then what will happen? This after prism, the light rays will go like this. Light will deviate. So same plane wavefront I will get. Same plane wavefront I will get. So whenever light or plane wavefront passes through the prism, then we get a same plane wavefront. And a plane, but it is tilted is there. Yes or no? Clear? Now number 2. Now if I take a convex lens and my object is at focus, object is at focus. Now where its image will form? Where its image will form? Object at focus. Image will form at infinity. So infinity, this ray gone, the ray will be parallel. Parallel means this is which these are all plane wavefront. Which wavefront? Plane wavefront. Okay, but here in object, what is the wavefront? What is the wavefront? Spherical. So here object is spherical wavefront, and image is coming. Image line or image range. Image is having plane wavefront. Here spherical wavefront. Number 3. Number 3, listen, silent please. Listen carefully, I'll tell other everything is there. Now one concave mirror is there. One concave mirror is there. Now here you have one object. Now here what will happen due to that also, whatever image I'll form now, that will be a spherical wavefront. Well, diagram given or not? Concave mirror. Okay. Now if I'll keep an object here, a parallel light ray coming and hitting here, going like this. Another parallel light coming and hitting and going like this. This is the focus. So here whatever wavefront I am getting, the spherical wavefront. Radius how much? Radius is f. F equal to r by 2. R is radius of the mirror. Here also same thing happening. But here another thing I'll tell you. When lens is there, if parallel light rays are coming, after refraction it will meet through the focus. This one you know. So that means when object is infinite. Object infinity means what? Parallel ray. So plane wavefront. So when plane wavefront is coming, then image at focus. What is this one? This is the focal length of lens. Focal length of the lens. Okay. So that means I can tell here. What I can tell, say? This is spherical wavefront. Image formation is spherical wavefront with radius f. Small f. I cannot write r by 2 because I am talking about here r by 2 I can tell now. Lens. So I cannot tell r by 2. R is the radius of mirror, that's why it is r by 2. Okay. So all the points are there. You check everyone. Don't think that I am writing here and there. This one. All are there. So remember how the question will be. Question any one you have to draw. They'll tell object at focus. You draw for a convex lens. What will be the image wavefront? You draw that. You write it is the image of a plane wavefront. You do like this. Or one given like this one also check. In book it is given like this. Yes or no? They'll tell object at infinity how the image wavefront. Image will be, this is the image point always remember. I object. Your object I. Your object, this is I here. Okay. Yes or no? Object image. So this idea keep in mind. Now next point come. Come to next point. Practice well that one. Coherent and incoherent sources. Printing mistake is there, you can check that now. Okay. So now write next heading coherent and incoherent sources. So here you write coherent, here you write incoherent. Shortcut idea I'll give you, try to remember. In classwork you written, definition written you can take. See here source, coherent source basically. Source with which emits radiation or light, emits light with the same lambda frequency and constant phase, they are called basically coherent sources. Okay, but here what? Here lambda is not same, lambda and frequency not same, and coherent phase is not constant. H is not constant. That's why this is incoherent sources. Now another point, suppose you want to write here phi does not change with t. Phi does not change with t. But here phi changes. Phi means phase. Phi changes. Okay, with respect to. So be careful this one. Now what is the example of current sources? I'll give you a laser light. LESER, laser. Or here I'll give you bulb. Or I'll give you sunlight. So these are the examples of what? Examples of coherent sources, incoherent sources. Same points are given or not given? Okay, if anything missing is there, coherent, incoherent, please rectify that. You missing what you are telling? You are telling anything? Huh? What happened, ma? Okay. So coherent, incoherent. Did you understand? Laser light na, if laser light will come here, straight parallel light will come. Here wavelength will be lambda. So it will be monochromatic light. Remember, mono means single. Chromatic means color. Monochromatic means single color wavelength. So laser light now only single color wavelength will come. But is white light now many wavelengths are there. Okay, are understanding? Now next thing is the bulb and sunlight are white light. So unpolarized light they have incoherent sources. The wavelength of frequency not same. Now laser light is monochromatic. Suppose the opposite of monochromatic, what will tell? So many wavelengths are there. Polychromatic. Okay. Yes or no? Polychroma. Polychroma means color. So coherent source, incoherent source, no doubt. You understood. So up to what point I completed? Reflection and coherent, incoherent sources, right? Now you write in classwork. Right. Write that again. I'll come. Interference other. Right, ma? Morning you are writing now something. You have to start. Don't you start means you have to start. Don't take tension. Pay attention. Listen to me. One day I sent a song you saw. That's one day by mistake one song you sent in group. 12th. You saw. That's what you thought. Why are you sending there? My kid is sent by mistake. So I deleted. What you thought by seeing that? By mistakes are sent. I'm telling you only. I'm telling you because that before that 2 days they played with me. Okay. So tricky freaky they did na, that is a okay game when you are playing you fell down yourself. Huh? Oh. Simon sir have you seen no? Mental like some behavior doing while going na doing like this. Doing like this. Huh? That means he should have become some cricketer. So by mistake became teacher. Thanks. Simon sir when he go na doing like this. Doing like this. That means defense out. Right ma? Everyone listen. You don't have a plan, that's why you are horrible, you are happening. Listen. One period, 3 topic. Okay. 20 minutes explanation, 20 minutes write. That's it over. One period over. Yes or no? So you write. I explained you now. Then why you should not write? If any doubt in picture and all, you comment ask me. Anyhow, if I should have taught everything, you should have written na. The same thing only. I explained 3 topic. Like this means it is implying that this one is a one distance. That distance is v2x. V to tau, not x. V to tau. So 5 changes, valve, everything understood.